All right, hi guys. We are going to start our second half of Unit 2, and we've been working on scale images. We just had our quiz on scale factors, and we learned that we always multiply to increase or to scale up, and that we always divide to scale down. So now we're going to continue with that kind of. And we're going to do dilations, and I've combined these two lessons and kind of taken out some of the stuff that I think we don't really need to go over, and I've kind of compressed it. We will go over tomorrow anything that you don't get from this video and the class today. So if you don't get it, totally fine, circle it, put a question mark next to it, and we will address that tomorrow. There's no practice problems in this packet, so it's just all the lesson, and we'll see how you do, and you can continue and try some of them, but tomorrow will be the practice portion, so we'll kind of divide that up. All right, so your warm-up for today is this image. I want you guys to take about 5 minutes. I'm going to set about a 5-minute timer, and I want you to look at it and make a little list. You can do some bullet points of what you notice about the image and then what you wonder. What are some things that you're kind of wondering about and what you notice? So pause this video and then work on that and then come right back and we'll see if we have some of the same stuff listed. Alrighty, so I'm looking at this picture, and what I notice is that we've got lots of circles. So we've got like the smallest circle here. Oops. And then they get bigger and bigger, and it's not the biggest circle, but we've got a larger circle here. It's just not a great highlighting job at the time. And then we've got some little ones in between. So we have a center point. Something I notice is they all have the same midpoint. Okay. And you can add to this, you might have some stuff that's different. All right, I also notice that they all have the same kind of, between every circle, they're the same difference. And we can take our ruler and we can measure between, and I'm at about 5, 6, 7, 8, 8/10 of a centimeter. You can measure again here, about 8/10 of a centimeter. Is this the same? Yep, about 8/10. So the radius of the smallest circle is 8/10 of a centimeter. So that means, since this is 8/10 and this is 8/10, that each circle, if we scale up, what's the scale factor? What's happening between this smallest circle and the next one out? What's the scale factor between that smallest and biggest? All right, so hopefully you said the scale factor is 2. So each scale factor radius doubles, and that doubling means it's times 2 is our scale factor. All right, and then the next one would triple, the next one would quadruple, the next one would be times 5. All right, so that's the scale factor that I notice. They're all split into 6 sections. So if you looked at the circle, you had 1, 2, 3, 4, 5. Oh, actually, sorry. 7, 8, 9, 10, 11, 12 sections. There's 6 rays coming out of the middle. 6 sections, and there's 12 sections. I mean, there's 6 lines coming out from in between. What did we remember from last time? If we scale up or down, do our angles change? So do these, let me find another pen. Do these little angle measurements change as we move out and get larger? No. The angle measurements are all congruent and they don't change. Okay. And there might have been some more things. I think if you're going over this with Sierra, there are more things that you might notice. They're scaling down. You can see they scale down by a double or whatever. So there's a lot of stuff that we have. So this is kind of dilation. The getting larger or smaller and having a center point. This center point or this point of dilation is really something important. So that is what I want you guys to know. Alrighty. So some terms that I want you to know, that I want you to add, is what is a center of dilation. And you can write this on the side, or you can write this on your graph paper from your notebook. So a center of dilation is a fixed point, meaning it's not going to move. We're not going to have the center of dilation here and then move over. It'll stay and everything kind of dilates out or in from that point. It's a fixed point on a plane, and a plane is one-dimensional, just a flat surface. And it is the starting point in which we measure distances. Okay, so our next exercise, we're going to measure. It's going to say dilate 2 with a factor of 2, or dilate with a half. And we're going to work from that center point. All right, and then what is a dilation? That is our other term I want you guys to know. So dilation is basically scaling. I'm trying to put this into easier terms. Scaling up or down in size from a center of dilation. Okay. We can dilate on just a flat plane. We can dilate with a grid, which we're going to do next. Okay, but that's it. Alrighty, if I went too fast, and pause and copy it. All right. So this is our next task. We're going to do this. I'm going to give you guys maybe about 5 to 7 minutes, and you're going to dilate this polygon. So let's just go over. So we've got a polygon ABCD, and this is our original image. There's 3 things that you guys are going to do. The first thing is you're going to dilate each vertex. So the vertex are the angles. Vertex is another word for like angles of the polygon ABCD using our center point of P. We can highlight it if we want. Okay. And we're going to scale it up first at a factor of 2, and we're going to label our new image. We've got A, B, C, D as A prime, B prime, C prime, D prime for the vertices, and then afterwards after you've put the points, you're going to draw segments, you're going to connect them. Just connect the dots to make a new polygon. And then I want you to list what are some things that you notice about your new polygon, and you can list them here. All right, so you can do that for about 5 minutes. I'm going to pause the video and do it and see if you guys got the same thing as me. Alrighty, so now I have scaled my vertices out. So it's at a scale factor of 2. So since this is the center point, we're going to dilate out. And they're all kind of different if you notice. So this one is 1, 2, 3, 4 segments out from our circle. So 4 times 2, we're going to go another 4 or a total of 8. So 4, 5, 6, 7, 8. 4 out. Same thing here. This was 2. So I went another 2 for a total of 4. 2 times 2 is 4. This was 5, 1, 2, 3, 4, 5. So I need another 1, 2, 3, 4, 5 for a total of 10. And then this was 1, 2, 3, and then another 3. So we've dilated everything at a factor of 2 that was set up here. All right, now I'm going to connect my dots. All right, and hopefully you've listed things that you've noticed. If you haven't, I would pause and get to that. All right. All right. So some things that I notice is that all of the angles are congruent. Kind of like what we said is these angles and these angles, if we were to take our protractor, let me pause and I'll go get it. And there's some protractors on my desk. You guys can use them. All right, so we're going to measure. Remember, we're going to put our vertex, the little dot in the middle. I'm going to line up the lines. And this is about 53 degrees. Let's see, it's the same. I didn't extend it, but it's about 53 degrees. So our angle measurements don't change. They are all congruent. A to A prime, same thing. So these are congruent to each other. And then B and B prime are congruent. They didn't change. They did not change. What else did you remember? Did you notice? Did you guys measure your sides out? Okay, so let's measure this one. It's about 3.5 or 3 3/10. And this is 6 and 5, 6, 7, 8, 6, 7, funny. 8. So they kind of doubled. So if you wanted to, yeah, I think it's 6/10. They doubled. Okay, so the sides doubled. So that's our scale factor of times 2. All right, so those are some things that we can notice. If you measured them all, that's what it is. And then that's at center point. It's not moving. We're dilating out of there. We're scale factoring out of there. And if we looked at it, this is a scale copy of the original. All right, so the next part of this, I want you guys to take another 5 minutes to do this. Dilate each vertex of polygon ABCD, the original, using center P as a dilation and a scale factor of 1/2. So now we're going to scale down 1/2. You're going to label this new image E, F, G, H. So wherever there's A is going to become E, F, G, and H, and it's all there. And then list some things that you noticed. All right, I'm going to pause it. I'm going to scale mine down 1/2, list some things that I noticed, and let's see if we get the same thing. Alrighty, so I plotted my points, and I'm going to connect them. And then what are some things that you notice? So kind of the same thing as up here. And you guys can list them, pause, talk about it with each other as a class. What are some things that you noticed? And maybe you guys can list them here, or you can whatever. All right, so some things I noticed again. All of these angles are congruent. So all corresponding angles are congruent. All right, all of these sides are parallel. Okay, we didn't say this up here, but if you look, the largest, the medium, and the small are all parallel. So all corresponding sides are parallel. Say E, F, G, H is 1/2 of A, B, C, D, but how does E, F, G, H correspond to the larger one? So we could count, and that's what's great about scaling, is that we can count them. This one might have been interesting in here. So this one was 1, 2, 3, a measurement of 3 from P. Half of that was 1.5, and this one was 5, so it was 2.5. I don't know if you guys picked up on that. But EFGH is half of ABCD, and if we go, we can go with an easy one. 1 versus 1, 2, 3, 4. It's a fourth of the large one. So it's half of ABCD, and it's a fourth of A prime, B prime, C prime, D prime. All right. You can also, you don't have to dilate just off grid points. You could pick any point on a side, and you could, let's say we pick this one, and we dilate out. So what's the distance of this point from center piece? We could say, hey, I'm going to go up 1, 2, and then, or 3, and then over 1.5. And this one would correlate to, hold on, over here. Hold on, actually, 1, 2, 3, 1, 2, 1, 2. I think it would actually be right here. Sorry. So we go 4. So if you looked at it, other points can also dilate up. And the great thing about it is dilations can on a grid, you can just count. You don't have to measure it. You can do a lot of counting. Same thing here. All right. Hopefully you guys are getting the hang of what dilations are. All right. Let's put our learning target. What are some things that you've noticed that you can do now that you have looked at dilations? So here, you might not have noticed it, but these are all dilations. So you're looking at them, and then also creating dilations. And what have you noticed? So remember, they're all I can statements. So what can you do? I would say you can create a dilation. If you guys want to pause and you don't have to, and you guys can brainstorm, and Sierra's got the key for this, and see what you guys came up with without me telling you. All right, so you can create a dilation. You can also notice or recognize dilations. Okay, you can apply. Okay. Using a grid or a ruler. And you can also notice them using that ruler. We measured the sides. All right, and you can apply dilations using a grid or a ruler, and you can also apply them on a grid when the dilation is or has a center of dilation. All right, now we're going to step it up. And this is kind of a little fun because the dilation on this one down below, the center isn't actually in the middle of our image like we had here. This was really kind of easy. We just made it larger, made it smaller. All right, so now we've got a triangle. Let's see if you can figure out how to dilate off of T using a scale factor of 2.5. And I want you to pause and maybe take 10 minutes. We are about maybe 40 minutes into it. How would you dilate and make a triangle that is a scale factor of 2? So we know it's going to get bigger, scaling up by 2. And a scale factor of 1/2. How is it going to get 1/2? All right, pause. Use your rulers so you have a nice straight edge. I have some extras in my cabinet behind the podium. But take a few minutes, and I would say maybe 5 to 7, 10 minutes, whatever. All right, and then come back. I'm going to pause and make my own. Alrighty. So I haven't actually made my triangle. I've just plotted my points. And if you're like, I have no idea how to get to this, I could count, but it's not like a perfect circular line like the last one. Well, we do have this grid. We have these like coordinate kind of planes, like, X and Y. So what is our distance from T to Q? And I know I want to scale up by 2. So my distance from T to Q was up 1 over 3. So I want it to be twice as much. So I'm going to go up another 1 over 3. And this kind of leads towards our slope that we're going to do next. So up 1 over 3 is the same as up 2 over 6. So we say up 1 over 3 times 2 is the same as up 2 over 6. And that's my new point. All right, same thing here. So for R, I went down 1 over 4. Or, sorry, from T, it's down 1 over 4. Let me do another color. Down 1 over 4. So I'm going to go down another 1 over 4. All right, if you guys were stuck, see if you can figure out how I got from this T to this S, and then this T to the S prime, or from S to S prime. Alrighty, it was 2 and 2, and then another 2 and 2. So now I have my new triangle, and I'm going to connect the dots, and I've got my new one. All right, now scale down by a half. I'm not going to show you how I did it. Let's see if we can figure it out on our own. Alrighty, so we just did half of it. We went up 1 over 3. Now we're going to go up half over 1 and a half. We went down 2 over 2, down 1 over 1. We just did every little step, half of it. For this one, it was 1 and 4, so we did half and 2. And your little triangle can look like this. And we can name it, I don't know, ABC, whatever you want to name it. All right, so this has been dilated or scaled down a half and dilated up twice. And that is using a grid, but also not having our center of dilation in the center of our picture. So our center of dilation was T, and we dilated out from that point. And it's fixed, it didn't move. All right, well, great job. If you guys still have time, there is a card sorting activity. I've cut up all of these little cards. There's 6 packets of them. They're all the same, and you have to just pair them up. There's a polygon, and these are the vertices. And here's this triangle was dilated using center 0, 0, which is our origin, and a scale factor of 2. What would our new scale be? Can you find the card that matches to it? And there's all different ones. There's triangles, there's smaller triangles. I think there's some circles. But if you guys have time, you can, there's a trapezoid, another trapezoid, yeah, they're different, and some circles. All right, so see if you can figure it out. If you do not get to this, totally fine. We can do it tomorrow. So that's the card sorting activity. If you guys want to try this one's kind of a challenge. Triangle EFG was created dilating ABC using a scale factor of 2, and HIJ was scaled down. Okay, so it's kind of the same thing we just did, and the center point was D. What would the image look like under a dilation using a scale factor 0? What do you think that would look like? What would the image look like under a dilation scale factor of a -1? If possible, can you draw it? And what happens to a shape if it's dilated with a negative scale factor? Dilating with a nail, is it possible or is it not possible? I think if you guys have gotten the hang of it, I'd like you to try this one for homework, just to kind of think a little bit further and deeper. If you guys really struggled with it, and I'm going to trust Sierra with this, if you guys really struggled with it, don't do this one. But I'd like to see you guys see how you do it. All right, thanks. Great job, guys, and I will see you tomorrow. Bye.